The one test your software should definitely have before its first deployment is a smoke test. And the smoke testing strategy I'm presenting in this video is so cheap to implement that there's hardly any excuse not to apply it to every project. Here's the idea. The backbone of this smoke testing strategy is a fail-fast approach. That means treating every unknown or unexpected state or value with an exception. The most explicit way to achieve this is by using design by contract, validating preconditions of functions, and enforcing object invariance. The smoke test itself runs on the real system, at least the backend, without any stubs or mocks. It touches every major scenario at least once, passing either default or random input data. For every scenario, the test simply verifies that no error occurred. For a web API, such a smoke test might look like this. We start the system under test as a separate process and wait until it's fully launched. Next, we query all available APIs from the web API directly. This example uses .NET Reflection, but similar approaches work in other languages too. Then we create a route for each web API using either default or random values. Instead of hard coding defaults in the test, I recommend providing a dedicated web API that the test can call to download these values from the system under test. Finally, we call each route and verify that it returns HTTP 200. In other words, that it works without errors. A reference implementation of the smoke test you can find on GitHub. For a web app with a user interface, a smoke test might look like this. First we install Cypress and the Cypress fail on console error package as development dependencies. This test assumes that the frontend is already running. It starts by visiting the home page of the app and then recursively follows every link that points to a local route until all pages have been visited. If any page logs an error for any reason, the test fails. A reference implementation of this smoke test you can also find on GitHub. From my perspective, smoke testing is an essential pillar of a good testing strategy. The type of smoke test discussed in this video is quite cheap to create and maintain. It complements your acceptance test by closing test gaps, as it also covers integration, composition, and I/O code, areas that acceptance tests often skip. An example of a test gap that a smoke test like this could have caught, I reveal in this video. You definitely don't want to miss it.